Okay, hello, Ravika. Sorry, Kirti. I'm sharing my screen. Fine. Okay. So, can you tell me which topic we have discussed last class? Okay, okay. Just started NumPy, no? Okay, okay. Arrange. You get it? Okay, fine. So, let me start with the. So basically, NumPy is I am starting start this class from beginning of the NumPy. Fine. Okay. So NumPy is basically used for the numerical calculation and basically for the matrix, the the matrix data. You don't get that matrix data. Okay. Now it is. Yeah. Tell me. Okay. So I am telling you that NumPy is basically used for the mathematical calculation and which contain the data in the matrix form of matrix. Okay. So I already explained you what is matrix. So shall I explain is again or what? Yeah, fine. So basically, matrix is the syllabus of. I think you will see into the ninth or a 10th class. Fine. So you are in a seventh class right now. Okay. Hello. So you are in a seventh standard, right? But you will get the matrix in a mathematics in a ninth or a 10th. Okay. Okay. But don't worry. I'm going to explain this. What is matrix? So let me get a. You want a notebook? Hello. Otherwise, see, listen. Otherwise, I will put into the note. Don't write it. I will put into the note. Fine. Else you can whenever you repeat the video, you can download note from the video. Okay. Okay. Let me find. See, uh, let's suppose we have a set of data like this. Let me, let's suppose. Uh, okay, this is matrix one, first matrix. Okay. Let's suppose we have a one more matrix like this. Let's suppose we have a 10, then 11, then 15, 12, 18, 20, and anything else like 2, 3. So, okay, so we have two matrix. Matrix one, that is, this is, I put A equal to this and B equal to this. So this is called A matrix, this is called B matrix. Fine. Hello? Hello? Me. You are here, no? So this is two matrix, the matrix A and a matrix B. Fine. So whenever we get the data like this under this square bracket, this is called the matrix. Fine. So we can do anything like addition, subtraction, division, multiplication, anything with this data. Let's suppose if I say matrix A plus matrix B, then how it will give the result? It give the result like this. See, this is one, right? And this is 10. So if I do the summation of this, so 1 plus 10, it's 11. And 2 plus 11, that is 13. Then 3 plus 15, 18. After 4 plus 12, sorry, 16. And 5 plus 18, 23. After that, 6 plus 20, 26. 3 plus 1, 4. 1 plus 2, 3. 2 plus 4, 6. So this is called the matrix. So matrix A, matrix B, and if I do the sum of these two matrix, this is the result. Fine. You got? So basically, this kind of calculation we can do by NumPy. Got it? Now you have cleared the matrix. What is matrix? Okay. Now let's go to the Python. We can do all this in the Python. Python. See this. Uh, to use NumPy, we have to write like this: import NumPy as a NP. Got it? Hello? Okay. Let's suppose I'm writing a equal to 1, 2, 3, b equal to just do the summation like this. Okay, just hold on. Okay, okay, we have to make an array. Okay, okay, just np dot array. Okay, now let me try this. See, hello. Let's do the summation of sum of the two matrix. The matrix one, matrix A and matrix B. Let's do the summation like this. So 5 plus 1 it's 6, 6 plus 2 it's 8, and 7 plus 3 it's 10. Okay, good. So NumPy is basically used for the matrix in a Python, and you know this is the matrix. This is the matrix. The data we make the data like this. Okay, let's move. Let's move step by step. So for NumPy, basic for data analysis, importing NumPy. Import NumPy as NP. Hello? Yeah, waiting. You yes. Okay, so if you want to use the NumPy, we have to write like this: import NumPy, and as a NP. NP is what? I am writing this NumPy as a short form. That is NP. So import NumPy as a NP, because we don't need to write every time full spelling NumPy. We can write only NP. So let's use your headphone. Your voice is low. Uh, I will give you the guideline. You can download it. Just go to this topics. I will guide you how to install the NumPy. Okay, don't you worry. I will guide you. Just go through these topics. I will guide you how to install NumPy into the Python. Okay. So creating an array, 1D array, 2D array, and 3D array. This is called the array. Here, this is one-dimensional array. Here, this is one-dimensional array. Fine. Let's check then. So if I write a equal to like this is called the one-dimensional array. If I put one more square bracket, this is called the two-dimensional array. How? Just see this. Okay, let me see this. Let me show you one thing, and then see. If I print, okay, I'm going to comment this, and then I'm writing print a dot n dimension. Just a minute. A and fine. So print a dot ndim will tell us what is the dimension of this matrix. Let's check this. Here, What is the dimension? Hello? One. One dimension. Fine. If I give one more square bracket, then see. Now what Python will say. It's two. If I put this square bracket one more, it become two dimension. If I put one more, now check this. Three dimension. Okay. So you get how we can write the one dimensional matrix, two dimensional matrix, and three dimensional matrix. Yes, perfect, perfect. So let's. So we have already clear what is one dimensional matrix, two dimensional matrix, and three dimensional matrix. Fine, and we check it how it's look like. Okay. Now let me show you one more thing like this. If I write, yeah, let me explain you. See, this is called the three-dimensional array because we have three rows and three columns. Fine. What it if we write no. If I write like this, one, two, three. How many dimensions? One dimensions. If I write like this, one, two, three, then six, seven, eight. How many dimensions? Uh, uh, two dimensions because one, two. But we have a column, three columns. One column, two column, three columns. Okay, fine. So then, okay, fine. Then we can print like this. See this. This is the two dimension because this is a two dimension and we use this two square bracket. No, that's why. Okay. Similarly, for three dimensions, if I put like this, the C option, copy this, and I can give one more print. See, fine. Now check this. Even let me give one more thing. Now okay. So we have given the all the three. So let me move. Then we go on the now perfect. See, so this is the one dimensional, and this is two dimensional, and then three dimensional. If I put some more things under that, then you can get more clear idea. Then here 2, 4, 6. After that 3, 6, 9. See all the examples at a time. One dimensional, two dimensional, and the three dimensional. Like this. Got it? Fine. Let's move. Move for the next one. Okay. After that, a special array. Let's suppose if I put like this, np zeros, np 0 2 3, print array. Let me put this. You want to go for? Yeah, yeah. Go. Okay. Okay. See, I'm writing a program which give us matrix with zero value, and the dimensions of matrix will be 2, and column will be 3. Okay. So just write import numpy as a np, then array, give a name array, and then np dot 0, because we put 0 it will put 0 value. Then 2 3, 2 means 2 dimensional and 3 means 3 column. So let's see how it will give the answer. And then print, sorry. Okay. See, 0 0 0 0, all the places of column 1, column 2, column 3, all the values are 0, because we write np dot 0, and 2 means 2 dimension and 3 means 3 column. If I put here 3, now check. See this, 3 dimensional and 3 column matrix. Got it? It will give 0 under the matrix. All the values are 0 under this this matrix. Now check for the other one. If I put 1 like this, 1, and then I run this program. Let me make this 1. See 1 1 1. All the value in a first matrix, the first row and first column, and second row, second column, all the values become 1 because we put 1 here, np dot 1. Similarly, if I put I dot 3 like this, let me make this comment. If I run this, see diagonally it puts 1 diagonally. Got it? So when we put I3, it will put like this. If I make this 2, let me see what kind of changes it will give. Python is slow today. See this. Two-dimensional and 1 1 at the diagonal value. Okay, we put 2, so it becomes two dimensional. Got it? Hello? I give a value of 1 at a diagonal place, diagonally. See, in matrix, we have a value like this. Let me give one more. So there is a matrix called diagonals matrix. So we have data in a diagonally like this. Okay, like this 1, then 0, then 0, again 0, 1, then 0, 0, 0, 1. So this is called, I think, even I am forgetting what kind. Just a minute. Give the value in if I present diagonally, that is called diagonals matrix. Here, value I put here 1. Hello, 1 1 1. So we have a value in a diagonal place, not on the other place like this place, this place. We have got it. That's how we can create like this using this np dot I, and 2 is called the two-dimensional. If I put 3, it becomes the three-dimensional. Got it? Like this. So then we have to go for the next one. Then see this np dot arrange 10. If I put like this, see 1 to 3, sorry 1 to 10, up to 10 value. It's printed 10 value under the one dimensional matrix by using this. After that, if I put like this np dot line space 0 to 5 series, np dot line space 0 1 5. So it gives the value between 1 to 0 to 1, and how many values? That is 5 value. So let's start from 0. After that 0.25, then 0.5, then 0.75, then 1. These number are between the 1 to 10. If I write like this, give me the value between 1 to 10, 5 value. I want 5 value between 0 to 10. See this. Then 0, 2.5, 5, 7.5. Like this. If I write 9, like this will give the value between the 0 to 9. So we can use this np dot line space. Okay. Now array attributes. So we can know the shape of the matrix, dimensions of the matrix, then size, then data type. So this part is called the attributes. How we can know that? Just see this. Let's suppose we have matrix like this. Import numpy as np, a equal to np dot array. After that, print a shape. If I ask to the Python print or means this one, the a, this one, and then I want shape. What is the shape of this matrix? So see, 2 comma 3. It means 2 dimensional and 3 column. Got it? If I delete this like this, now check. 2 comma 2, because 2 dimensional and 2 column. Got it? So the shape option will give the shape of the matrix. After that, ndim. Ndim give the whether it is 2 dimensional or 3 dimensional, like that. See, if I write ndim, then see. Only 2, because we have a 2 bracket, square bracket. So it's a 2 dimensional. If I increase one square bracket, now it becomes the 3 dimensions. Let's ask with the Python. 3 dimensional. Got it? Okay. So we can use ndim to understand the dimensions of matrix. After that, size. We can use the size. See this. Four size. How? Because we have one value, two value, three value, and four value. We have four numeric value under the two matrix. The matrix this one and this matrix. If I increase this number, let's suppose I make it three. Again I make it six. Now let me check this. Now see how many size. What is the size of matrix? Hello. Sorry. Two dimensions is fine. And what is the size? So size is six because we have six. Sorry. Yeah. So first is give four because we have a four digit. Now it's give six because there is total six digit available under the matrix. So this is for the size option. Then data type, D type. If I put here D type, it will tell us what kind of data it is. Integer because this is 1, 2, 3, 4, 5, 6, 7 like this. So this is called integer, not float. If I put like this 0.2, 0.3, 0.5, 0.1, 0.2, 0.3. Now let me check. It's a float value now. Got it? So we have completed the array attributes. Now array indexing and slicing. Now we can do the slicing and indexing for this matrix. How we can do that? Let's see. If I put a 0 1, then see. If I write like this, import numpy as this and a equal to numpy dot array, and we give a matrix like this, and I want to print a 0 comma 1, then see what is the result. 0 row and column 1. So 0 row, column 1. Okay. 0 row and column 1, this printed this value. If I make this like this, 0 0 0 means this one, this one. Okay. Make it one dimensional. Now it become one dimensional. Is there any okay. 0 comma 0 means this place. Now if I change this like this, 0 comma 1, 0.2, because 0 means the first matrix and 1 means the column of the first matrix. If I change this like 1 and then I make this 0, now check this. this one, because one is the zero is the first matrix and one is the second matrix, and this zero is the this place. Start Python counting start from zero. Got it? Hello? No, how I can get the data from matrix like this? We can slice the data. Slicing like this. Cut this data. Cut from this place. I cut this data from this place using this print statement. Similarly, if I write like this, a square bracket then colon comma 1, see what we can get. A square bracket colon comma 1. So let's give 2.3, 5.2.3 and 5.2, because we give colon here, so it's ignore the first value, and I write here 1, so it will go to the second column, because 0 we escape 0, so this is 0, this is 0, but we write 1, so this is one place and this is the one place for second matrix, so it's print 2.3 and 5.3. Got it? Then row 1 and all column, so we can write like this. Here reverse case, opposite to this one. I'm going to write new one, print like this. I'm going to make it comment. Okay, now opposite to this value. Now check this. 4.1, then 5.6 and 6.3. 4.1, 4.1, then 5.2 and then 7. Entire, this entire column. The entire second matrix will be printed here. Row 1 and all column. All rows and column 1. All rows and column 1, like this. Got it? Here one rows and all column. One rows. These rows and all column for 1. If I make it 0, now check this. See, for this part, it will give the result like this. See this. All rows and column 1. All rows and column 1. So column 1 is this one as well as this one. Sorry, all rows and column 1. Column 1. So 2.3. Okay, it's fine. It's fine. And 5.2, because we put here 1, and this is start counting from 0 and then 1. 0 and then 1. So all rows, not all rows. It's all column. all column here and rows 1 like this. All rows, column. Perfect. So this is column 1, then this is column 1, and rows, all rows, these rows and these rows. So it's printed value here. And this is the reverse case. What I put here 0. So 0 matrix is this one, the first matrix, and all column. So under the first matrix, the all column, this column. So it's printed here. Okay. And for this sub array, we can write like this. 0, 2, and 1, 3. So 0, 2 means 2.3, 2.3, and then 3.5, 3.5. Okay. From 0 matrix to 2 and 3, and from matrix 1, these two parts, 5.2 and 6.3, like this. Okay. Give like this. 2.3 and then 5.2. 2.3 and 5.2. 0, 2, 0, 2, and 1. Okay. Okay. So for this program, if I write 0, 2, it means the first matrix and the second position. And for this, the first matrix and the second position. So it's printed value like this. Okay. So this is called the array indexing and slicing. We can indexing and do the slicing. Then array operation. Now let's do the mathematical operation. Let's suppose I am putting data like this. We have two matrix, matrix A and a matrix B. I am importing the numpy and putting a matrix 1 and matrix 2, that is matrix A and matrix B. Okay. If I want to do the summations like this, simply print okay. I want to do the summation of matrix. See, let's do the summation. We already seen this program in the beginning of our class today. Hello. So you are observing, understanding, no? So we are doing the summations of two matrix, that is matrix A and B. So 4 plus 1, this is the result, 5 plus 2, this is the result, and 6 plus 3. After that, let's suppose we can do multiplication. So simply change the sign and click this. Let's do the multiplication. 4 into 4, 1, 4 into 1, that is 4. 5 into 2, 10, and then 6 into 3. Let's do the multiplication. Similarly, if I do this, if I want to square, just give two multiplication sign. It will give this this value used as a power. See this. See, 1 to the power 4, it will give 1. 2 to the power 5, it will give 32. You know the power? What is the power? Hello? Hello? Yes. So you understand this. It will 1 to the power 4, that is 1. 2 to the power 5, that is 5. It means 2 to the power 5 means, see this. I want to say you like this. 2 to the power 5. Can you tell me the what we get the output? Hello? Hello? Yeah, yeah. Yeah, tell me. I hear you. No problem. No. What is the output? Correct, correct, correct. 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 32. Same thing Python is doing here. So 2 to the 5, because we give the double multiplication, so it's work as a power. 2 to power 5, it will 32. So 3 to 3 to the power 6, it gives 729. Got it? Okay, so we can use like this. Again, this is our last topic that we can close the class for today. Fine. We can start reshaping and flattering in the next class. So let's see. So aggregate function. So I am going to give the program like this. Okay, import numpy as a np and a equal to np dot array. Can you tell me what dimensions of this matrix it is according to the Python? Hello. Yeah, how many dimensions this is? Hello. Yeah, can you tell me the dimensions of this matrix? 2. Correct. Then I want np dot sum a. Np dot sum a. Ten. It's adding all the values of the matrix. 1, 2, 3, 3, 3, 6, 6 plus 4, 10. Here again, I want mean. I want mean. Okay, you know what is mean? Hello? You know, no? So sum of all the values divided by the number of the numerical data. So I think it will give 1, 2, 3, 4. 4 divided by 10. 10 by 2.5. Fine. How it come like this? Because we have a 4 digit here. See, 1, 2, 3, 4. Total 4 value and summation is 10. So 10 divided by 4. It will give 2.5. Got it? Okay. So this is after that maximum. If I want maximum, which which part is maximum? Simply write max. Under the matrix A, which value is max? Can you tell me? 4, no? Out of okay. So 4 is the greater one. And which one is the minimum one? Min. Which value is minimum? 1. Perfect. It's 1. Yes. Python is also saying 1. Okay, fine. So we have completed up to aggregate function. One more function is standard deviation. You know what is standard deviation? Standard deviation is the square root of the mean value. Okay, just see square root of the mean value. So mean value is 2.5, and the square root of 2.5 is this value. Let's let's ask to the chat GPT. Let me ask to the chat GPT. Okay, otherwise give some value. Okay, otherwise let me show you one data. See this. All the formulas are mean, median, mode, and then variance, and then the standard deviation. See this. Square root of variance is called as, sorry, I'm sorry. The variance, mean of this square root, and then variance. The square root of the variance is called the standard deviation. Got it? And what is variance? Variance is the mean difference between the mean as well as the digit divided by the total digit. That give the variance, and the square root of the variance give the standard deviation. No problem. We need not to calculate manually. The Python will give automatically these values. Fine. So this is the power of Python. We can directly get the value, mean, median, mode, anything. Got it? So we have done this up to aggregate function. Fine. So we can start the reshaping and the flattering from next class. Got it? Okay. Now in the next class I will show you the installation part also. How we can install the NumPy. Got it? Okay then. See you for today. Bye bye.